Well, hello there, my little Algebra 2 students. This is your well-rounded math teacher, Mr. Picard. And today we're going to work with exponential functions. Mostly we're going to be graphing them today. But explaining what an exponential function is, Sam is working in a biology class with a petri dish of bacteria. He estimates he has a colony of about 25 bacteria. Assuming the entire population of bacteria doubles every hour, find how much bacteria Sam will have after 5 hours. Now you can do this in a simple table, but I'm going to actually show you how to do it with a formula also. Okay. First we have the initial value at time 0. At 0 hours we have 25 bacteria. But after 1 hour that's going to double, giving me 50. After 2 hours we have 100. After 3 hours we're going to have double that, which is 200. After 4 hours, we'll have 400. And finally, after the 5th hour, how much bacteria will we have? We'll have 500 bacteria. So quite a bit in a 5-hour span. So that's an example of where it doubles. This is called exponential growth because it goes kind of slow in the beginning, 25 to 50 to 100. And then it really starts kicking up 200, 400, and then 800. And after that, it'd be 1600 for another hour and 3200 after that hour. So when we're working with exponential functions, the growth starts out slow, but it goes very fast after that. Now, you can use a table like this to figure out how many bacteria in this petri dish, but what if I said after 25 hours or 50 hours? Would you want to keep going with this table? Well, you could, but really it all goes under this little formula here. Y equals A times b to the x power, where y is your final amount. In this case we had 800, so y would be 800. You wouldn't know that in the beginning, but anyway. A is your initial amount, and that is 25. B is what we call our multiplier, what you are increasing it by every hour or whatever your timetable is. And being we said doubles it, that would be 2 right here. And x, that's your exponent, and that is a variable, okay? In this case, it was 5 because it was 5 hours. But sometimes time is in days or minutes or whatever like that. But here it is, y equals 25 times 2 to the 5th power. If you plug this in exactly like this into your calculator, you should get 800. Make sure you got your multiplier in parentheses. Now you might want to put a little multiplication symbol in between them, but you shouldn't have to. And to get this 5 to the 5th power here, make sure you use your caret key. So actually it's 25 times 2, caret key 5. If you plug it in like that, that's how you'd plug in this formula right here and get 800. Anyway, so this is the formula we're going to be working with. Y equals AB to the X. And let me look at this a little bit here. Okay, just some different graphs we've gone over in the past. Linear equations, y equals mx plus b, where you got your slope and your y-intercept here. Quadratic equations, that's where you're dealing with an x squared, y equals x squared, ax squared plus bx plus c, that kind of thing. And other polynomials that we've graphed a little bit. X cubed, we used our graphing calculator for most of these. X to the 4th and x to the 5th. Now we did do square roots and rational functions here. Square roots is basically where you find the domain and the range to find your starting point here. And then you make a little table from there. Same thing with rational functions. You're always looking at, we'll just say, I don't know, well this one, x over x minus 3. Well, x cannot equal 3 because if you plug 3 in here in the denominator, 3 minus 3 is 0, you can't divide by 0. Check Norris rule, just throwing that out there. That's why we have this vertical asymptote right here. And then we'd set up a table, graph a few points to the left of x and a few points to the right of x of that vertical asymptote and go from there. But now we're going to start graphing these exponential functions. Here it is once again. Y equals A is always your initial value, B is your multiplier, and then this x right here And the reason they call it an exponential function is because you have a variable at the exponential position, or the exponent. Right here, x is our exponent, hence the exponential functions. There's two types of exponential functions. That 2 right there is actually our b, not our a. If there's two numbers there, the first one's a and the second one's b, but if there's just one number, that is b. If b is greater than 0, or I'm sorry, if b is greater than 1, which it is, it's 2, you're going to get a graph that goes up like this as growth. Now, we have a horizontal asymptote, and that is the x-axis right here. Our graph is never going to go below the x-axis, okay? This is an example of growth because as it goes to the right, it goes up. Here, there is no a. Well, a is 1 in this case, but if there's only one number and it's to the x power, that's your b. And if b is less than 1, but greater than 0, in other words, between 0 and 1, it's going to be some fraction or some decimal like this 1/2. That's an example of exponential decay. Once again, it doesn't cross the x-axis. So we have growth right here and decay, both examples of exponential functions. They're not that hard to graph. They're actually pretty easy. So we're going to jump right into them. This graph right here, y equals 3 times 2 to the x. A is equal to 3 right here. That's my a, and b is equal to 2. That's my multiplier. They tell us a little bit. The first thing is this. I'm going to go right to 0. Because when x is equal to 0, that's where you're going to have your y-intercept. It's the same thing every time. It is always going to be right here, a. Why is that? Well, when you plug in 0 for x, okay, I get y equals 3 times 2 to the 0 power. There's my x right there, which is 0. Anything to the 0 power is equal to 1. So this becomes 3 times 1, or 3, which is your a. So I'm going to go over here and graph this. Over to 0, and then up 1, 2, 3. There's my y-intercept. And then from there, you'll graph a couple points to the right of that, 1 and 2, and a couple points to the left of that, -1 and -2. And I don't know, you can plug in -3, you don't have to. I'm just going to go right to -2. And when you do this, you're going to want to use your graphing calculator or some kind of calculator, because when you plug in, we're going to plug in -2 now. Y equals 3 times 2 to the -2 power. Well, what is that? Well, plug it into your graphing calculator. It's not going to come out the way you want it. Okay, I'm back again here. Anyway, I'm only going to show you this once. What this really is 3. You can't have negative exponents. You can't evaluate them. So you have to flip this down to into the denominator, make it positive. So it's 3, and this 2 to the -2 power becomes 2 to the +2 power here. So this is actually equal to 3/4, or 0.75. Now you don't have to do all that work. All you have to do is plug it into your calculator. It'd be 3 times 2 in parentheses. Use your little caret key and then plug in -2 and hit enter, and you'll get 0.75. So -2, 0.75 is right about here. I'm going to plug in -1. Y equals 3 times 2 to the -1 power. If you plug this into your calculator, remember 3 times 2, caret key, -1, hit enter, and you should get 1.5. So -1, 1.5. So you can kind of see, now remember, it never crosses the x-axis. It's kind of going up like this. We need a couple more points here. Let's plug in 1. Y equals 3 times 2 to the first. Well, 2 to the first is simply just 2, so this is 3 times 2, or just 6. So over 1, up 1, 2, 3, 4, 5, 6 right there. And finally, plugging in 2. Y equals 3 times 2 squared. That's 3 times 4, or 12. So when I plug in 2, I get 3, 6, 9, 12, right about here. So here's my graph. And this is an example of exponential growth. Goes up by a little bit more, double that. 2 times 3 is 6. 6 times 2 is you get up to 12. It's going up extremely fast once you get into the positive numbers. And there's your graph. You're all done. And this is growth because right here, B is greater than 1. These both have to be positive. 3 and 2 both have to be positive, your A and B. Otherwise, it's not going to be growth or decay. And graphing this one. Well, let's find our y-intercept first. And that's where you're going to plug in 0 for your x, or your exponent. So I'm going to get y equals 2 times 1/2 to the 0 power. Anything to the 0 power is 1, so 1/2 to the 0 power becomes 2 times 1. Once again, 1/2 to the 0 power is 1 right here. And 2 times 1 is 2. Now notice my y-intercept is A. It's always going to be your y-intercept. So I'm going to go over here, and I'm going to go to 0, and then up 1, 2. There it is. So your y-intercept is pretty easy to find. Graph a couple points before x is 0 and a couple points after, and you should be good to go. So let's plug in -2. Y equals 2 times 1/2 to the -2 power. And I think I get, let me think about this a minute, I get 8. You try it. Plug it into your calculator. Remember, use the caret key for the -2. Put 1/2 in your calculator like this. If you're going to plug this into your calculator, it'd be 2 times 1. Use the divided by button, 2, and parentheses, then do caret key and -2 and hit enter, and you should get 8. So -2, 1, 2, 3, 4, 5, 6, 7, 8 right there. Plug in -1 now, do it down here, y equals 2 times 1/2 to the -1 power, and you're going to get 4. So -1, 1, 2, 3, 4. And you can see this now. Instead of, as I'm going to the right, I'm going down. This is decay. Once again, it's decay because my B is less than 1. B is less than 1 and greater than 0. Can't be negative. You guys plug in 1 and hit pause right now. Plug in 1 and 2 and see what you get. You can use your calculator. Plug it in just like we did over here. Okay. Hit pause now and try it. Okay, you're back. All right, that's awesome. So when I plug in 1, I get 1. So 1, 1. And when I plug in 2, I get 1/2. Or you could say 0.5, same thing. Right here. And it's coming down, and it'll never cross the x-axis. And we're done. Now, someone here is going to give you your worksheet for the day. You have to do 1 through 4. As soon as you've done 1 through 4, you can show it to the teachers in here. And if you are proficient, you got to show them your grade sheet with everything done and this worksheet. And then you are proficient, you may leave. Have a great Sunday, or whatever day is tomorrow. Thank you very much.